All right. Probably one of the more used versions of loans is something called an open-ended loan, better known as, well, one version of it, credit cards. So if you have a credit card, um, to find the interest is really difficult unless you get a bill, it has a specific balance, and you make zero charges throughout the month, and you only make a payment at the very end of the cycle. Then you can treat it like a regular car loan. The problem is credit cards generally have minimum payments that are really small, so you're basically just paying off the interest and not much of the principal. And another thing is that with credit cards, you're constantly increasing the balance by making charges, and once a month, you're decreasing the balance by making payments. So the balance or the principal of this loan is fluctuating as time goes by. So the way they go about finding the interest to be charged per billing cycle, um, they use this thing called average daily balance. Now, in Mobius, I describe how this actually works in very much detail of the process that I'm going to go through and why it actually makes sense. I just didn't want to spend a lot of time with that with the video because I think it's more important just to be able to do the mechanics of this one. But if you're curious about why it works and why it's basically fair, um, pay attention to the warm-up 33A in Mobius. So average daily balance, you can tell if your credit card is using this method because usually if you turn over a bill, oh, oops, um, it'll talk about the ADB, which is also known as the average daily balance. All right, so let's go about finding what this really means and how does it apply to a regular credit card. All right, so here I've just made up an example. Mary got a credit card that charges 19% APR, and her most recent bill that closed on July 14th had a balance of 379. And then she did some charges, 220, $87, and then a payment got posted. Now, just because she puts a payment in the mail means absolutely nothing. Um, the company has to open the mail, take out the check, and then post it to her account. So generally, there's a little bit of a lag time in there. So you pay interest up to July 29th on your previous balance, and then the payment of 500 will post. So what we need to do is find the interest that'll be added to the next closing date, and while we're at it, we'll find the new balance. All right. So to do this, we're going to set up a basically a spreadsheet, a chart, and this chart is going to have all the information from the problem put in it. So over here, we're going to have our dates. Make sure we have the starting date and the closing date. We're going to put our charges in one column. We'll put our payments in another column, and then we'll have all our balances here. So up until that point, it's kind of like a check register, except that check registers are backwards to credit cards. When you write a check, you subtract it from the balance that you have in your checking account. When you make a charge, you're going to add it to your balance. You'll owe more money to the bank. All right, so to do this then, we just need to, oops, pick a color. We're going to take this $220, since it's a charge, we're going to add it to our balance. So that becomes $5.99. And then there's another charge here, so we're going to add it to our previous balance. So we would get, that's almost 600, so it would be 686. And then we turn around and on July 29th, this is a payment, so it's going to subtract from the balance, and we're going to remove $500 from our balance, so that brings us down to $186. All right, so be really careful with this step because once you mess up one number, the whole process gets thrown out of whack. Okay, so the next column is what I consider the days at that balance. So when we're looking at $379, it was on the account from July 14th to July 17th. So the balance of 379 was there for 3 days. All right, then there was the balance of 599, and it was on the account from July 17th to July 22nd, so that's a total of 5 days. And then we're looking at $686. That was on the account from July 22nd to July 29th. That's a total of 7 days. And then finally, the last balance, I'm just trying to find a new color. Let's go with pink. $186 was on the account from July 29th to July 14th. Now, this is the one that causes some difficulties. If it's in a month, all you have to do is subtract the two numbers and you get how many days. But if it's going from one month to the next, you have to know a few things. Number one, you have to know how many days are in July, well, basically in any of the months. So to find the number of days in a month, there's a neat little trick you can do, and it requires your fingers. So I'm going to try to draw some fingers here. Not a very good artist. Oh, that's horrible. So here's your hand, and we're ignoring our thumb. We're just dealing with fingers. And the way this technique works is you start on the top of one of your fingers, and that would be January. And then you come down here to the crevice, and that would be February. This would be March, April, May, June, July is here. So July has 31 days. And then you jump over here, you start over again, and that would be August, and August has 31 days. And then down to the bottom, September, to the top, October, bottom, November, top, December. So the only one we're curious about is, of course, July. So July has 31 days, so what we need to do is we can't jump right to August 14th. We first have to go to July 31st. So how many days from here to here? That would be 2 days. And then from here to August 14th would be another 14 days for a grand total of 16 days. Now, there's a double check you can do to make sure you did all this right, is add up all of these numbers, and your sum should be the number of days that are in July, the month that you started in. So 16 plus 7 is 23, 23 plus 5 is 28, 28 plus 3 is 31. So I'm going to put that sum down here, 31. Okay, so the last column, you just have to remember that you're taking a product. So you're going to be multiplying the balance times the number of days that it sat at that balance. So you're going to go 379 times 3 and so forth and so on. Okay, so 379 times, well, actually, 379 times 3 is 1137. So this is 1137. All right, then we have 599 times 5, 2995. We have 686 times 7, 4802. And then finally we have 186 times 16, 2976. Now these numbers have really no meaning for us, so that's why I just call it product. Then we're going to take all of those numbers and we're going to add them all up. Because what we're looking for is the average daily balance. So after I add these all up, I'm going to divide by how many days in a month, and that should give us our ADB. All right, so 1137 plus 2995 plus 4802 plus 2976. 11910. And again, this number by itself means absolutely nothing. But the important part is taking these two numbers and using them to find the average daily balance. All right, so off to the side, calculator, 11,910 divided by 31. So our average daily balance is 384.19. Oops. 19. Now, this is just going to represent the principal of the account for the entire month. It is not one of the balances, so don't do any other calculations other than interest. So we're going to do interest based on $384.19, the 19% APR for 31 days. All right, so that would be, 384 times the interest rate of 19 over 100 times the number of days, which is 31 out of 365. Quiet. So the interest we owe is $6.20. So I'm going to add that as a new charge of $6.20. And it's going to add to my balance, which was $186. It is not this 384. You have to add it to the 186. So that would bring me to $6.20 plus 186. So 192.20. So the new balance that Mary will have to pay in the future is this $192. So that would be her new balance on her next credit card bill.